Hello students, how are you? I hope you all are doing great. In this video, we will continue our chapter number 6, Motion and Time. In this video, we will start from the topic Uniform Motion and Non-Uniform Motion. What is uniform motion and what is non-uniform motion? Let us find out. Uniform motion. When an object covers equal distance in equal interval of time, the motion is called uniform motion. For example, if a moving vehicle covers a distance of 10 km every hour, the motion of the vehicle is called uniform motion. Next is, what is non-uniform motion? When an object covers unequal distance in equal interval of time, the motion is called non-uniform motion. For example, if a moving vehicle covers a distance of 10 km in the first hour, covers a distance of 20 km in the second hour, covers a distance of 5 km in the third hour, etc., the motion of the vehicle is called non-uniform motion. Now, how we can differentiate uniform and non-uniform motion? In the uniform motion, car A travels equal distances in equal intervals of time, so it is in uniform motion. And in non-uniform motion, car B travels unequal distances in equal intervals of time, so it is said to be in non-uniform motion. Example of uniform motion is the movement of the hands of the clock. They move equal distances in equal interval of time. And the example of non-uniform motion is an athlete running in a race. So this is the difference between uniform motion and non-uniform motion. Next is time. Any change or movement which takes place is understood in terms of a physical dimension called time. Time and change are often linked together. Some natural events like the solar or the lunar eclipse happens once in a while. Other natural events repeat themselves over a regular interval of time. We refer to such regular repeating events as a periodic events. Measurement of time. The early scientists developed many devices to measure time intervals that are much smaller than a day. Devices like the sundial, the hourglass, and water glass were used to measure time. But nowadays, we depend on the clocks and watches to measure intervals of time. Clocks and watches are the time measuring devices that we use now. Most of the clocks makes use of some periodic motion. An oscillating simple pendulum is an example of periodic motion. So, next is a simple pendulum. A simple pendulum have a string with the mass at the end which is free to swing is called pendulum. The bob of the pendulum is free to oscillate. When the pendulum is at rest, it is in its mean or you can say equilibrium position. And when the bob of the pendulum is slightly displaced from its mean position, the bob undergoes a regular to and fro motion. One such complete to and fro motion is equivalent to the one oscillation of the pendulum. So, this is the simple pendulum. Next is distance time graph. Okay, next is using graph to describe motion, so we use distance time graph. We often use linear graphs to describe the motion of an object. One on such a graph, we generally choose the x-axis as the time axis and the y-axis as the distance axis. Okay, so how we plot the distance time graph? By following the different steps. Let us check out. We choose appropriate scales to present values of distance and time on the graph. The scale should not be too large or too small. It should be such that it enables us to utilize the maximum part of the graph. Mark the values for the distance and time according to the scale. Mark the points on the graph according to their values. Now join all the points on the graph. For this, for an object having a uniform motion, the distance time graph would be a straight line, okay, inclined to the time axis. So here the chapter is completed. I hope all the concepts are clear to you. Thank you very much and take care.